just had a whole lot of ideas, and most of them came too quickly, one after the other, for me to even remember the first ones. So maybe this is all going to come out to nothing, but they were all to do with starting at the top and dividing, rather than trying to take a whole lot of broken stuff down at the bottom and turn it somehow into a non-broken, coherent whole. This doesn't seem to work, because everybody down at the bottom with their broken stuff has got a different idea of what the whole's supposed to be. We don't seem to be able to arrive at a common goal. So it's like Ullmann's agreement theorem. When you look at it from a point of view of Bayesian probabilities, starting from your limited personal experience, it seems like it's kind of surprising that you get any kind of convergence. But if you start at the top and work down, it doesn't seem so surprising. I don't remember the proof. I didn't remember and didn't have enough of the mechanics of Lebesgue measures and sample spaces and things to be able to understand it easily. But the proof of Ullmann's agreement theorem is so short that I suspect it's actually a top-down proof. I should look at it again instead of trying to talk about it when I can't even remember what it is. But it's in Julia Galef's talk on updating probabilities. I think that's what it is. I don't know why she's not making any videos anymore. I worry about that. She's absolutely brilliant, and I don't think she's done anything for 2 or 3 years. I don't know what she's up to. I hope it's something good. I'm sure it is. So, yeah, it always works better if you start from the whole and divide it up than if you start with a whole lot of pieces and try and figure out how it goes back together when you never saw it all in one piece to start with. And these ideas all ran together into ideas of recursive polymorphic types. Because there you have the same thing, a universally quantified type variable like alpha in a function from alpha to alpha is a whole, and you can substitute alpha for any other type you can make. And Girard, Lafont and Taylor keep on going on about this remarkable ability of these systems to, well, whatever, it's all modeled by coherent spaces, and they have these few properties that allow you to deal with huge logical complexity. I'm way out of my depth here. Anyway, so I was also thinking about pi calculus and the higher order pi calculus, where you can pass processes around as the higher order typed pi calculus. And thinking about an idea I once had for that basic software model I described in a blog post once about about switching channels and splitting channels and joining them again and doing all this. I came up with a kind of model that I thought might work for that, used based on just standard ML abstract types, and that was in that notebook that I gave away, and there was something there about that. But again, you started with a simple idea of a channel which only took one abstract type of message. It wasn't completely simple, that abstract type, but one of the options, it was either a message or it was a split. It either passed a message or it split the pipe into two. And I thought I had a way of assembling pipes just by passing things down them. And this allowed you to construct pipelines with processes in between them that were potentially enormously complex, so that if you're dealing with message streams in an operating system, you've got events of one type and another. You've got compound events that those Linux guys must have gone nuts trying to get the Linux device driver model to handle this shit. But it's, for example, when you have a trackpad or a touch screen which can track 4 different streams, so that you do this gesture recognition where you have one finger touching and moving a bit, and then another finger touching, and the two doing something together. So you've got a whole grammar of events. Excuse me. You've got this grammar of events that are coming down the tube. It's not just a single event. It's not just atomic events. They actually have a structure. And they could even have a kind of recursive structure. So you have start tracking, track point, end tracking. So that's a kind of grammar of events that you can't have track points without having started the tracking, because you've got to have a tracking number in the track point. And you can have these streams. In one event, you have a compound event consisting of 3 different streams, and they're tracking interleaved, but they have this overall grammatical structure. And I had a feeling, I still have a feeling, you can do this. You can do this with higher order typed pi calculus. And you should be able to pass filters down as events, so that you reprogram. And maybe this is what sounds to me like the computational equivalent of McKenna's self-programming machine elves. God, that guy was brilliant. Anyway, so I had all these ideas. They're all coming at once, and they connected to probabilities and the way you do probabilities with types. I wrote something about that once, but I can't remember what it was. I had this idea that probabilities were connected with types. So anyway, the ideas all came kind of on top of each other, and now There were so many of them, I can't remember which ones were good. They were all good, but sometimes it goes like that. It was connected to something else. I was connected to economics, because you've got this problem in economics. You want to have a common goal. You want to have an existential basis, because if you don't, well, we know what happens. Just look around you. You have one bunch of guys who decide that, we got to get to the moon in a hurry, and we're going to fuck all the poor people and leave them to dry up with the earthworms. You can't do technological development like that. Sorry, it's not me saying it, it's just a fact, right? And if you don't recognize that fact, you should fucking well not be doing anything. I'm getting angry now, I'm going to stop.